ईयर स्टूडेंट्स, अगर आप इन वीडियो लेक्चर्स का मैक्सिमम यूटिलाइजेशन करना चाहते हो तो आई थिंक आपको ये इंप्रूव सेशन डेफिनेटली फॉलो करना चाहिए और रिलीजियसली फॉलो करना चाहिए। इंप्रूव सेशन क्या है, इसका लिंक डिस्क्रिप्शन बॉक्स में है, तो जाओ उसको चेक करो। इसके अलावा अगर आप व्हाट्सएप ग्रुप ज्वाइन करना चाहते हो, और मुझे लगता है आपको करना भी चाहिए, तो आप क्या करो, हमारे वेबसाइट पे जाकर के अपने कॉन्टैक्ट डिटेल्स दे दो या फिर इस व्हाट्सएप नंबर पे जाकर के अपने कॉन्टैक्ट डिटेल्स दे दो, सो दैट हम आपको उसमें ऐड कर सके। चलो अब पढ़ना शुरू करते हैं।
Hi, in this video we'll be learning problem solving techniques in 2D motion, and here's a simple scenario. So I've tried to keep it as general as possible. So here's a particle 1 which is at a height of h1 from the ground, and then we have a particle 2 which is at a height of h2 from the ground, and the horizontal distance between them is r. Okay, and here is my origin, and the respective parameters are given, the theta1 theta2 values and u1 and u2 values, and I'm going to take this convention. Right hand side is going to be my positive I, and up is going to be my positive j. So let's see the what kind of equations we are going to deal with, and the position equations are going to look like. For the particle 1 is going to be x1 is u1 cos theta 1 t, and y1 is going to be h1 plus u1 sin theta 1 t minus half gt square. Now notice that I haven't written anything for this acceleration component in this x direction, because there is no acceleration in x, right? So these particles are going to be moving under the force of gravity, and it's going to act vertically, so there's no ax, so ax component is going to be 0, and this h1 is the initial y coordinate, and this y1 is the final y coordinate. Similarly, I hope these signs are making sense. This is positive and this is negative as per our convention. And similarly we can write the equation, position equation for particle 2. x2 will be r. This is positive r because it's initially at a distance of r in the positive direction, and minus u cos theta 2 t, and again y2 is going to be h2 plus u2 sin theta 2t minus half gt square. So I hope this whole equation, position equation is clear. Now let's talk about the velocity equation. Final velocity of particle 1 in x direction is u1 cos theta 1. Since there is no acceleration in x direction, so the horizontal velocity of both the particles are not going to change. So vx1 is going to be its initial horizontal velocity, that is u1 cos theta 1, and again for particle 2 it's going to be minus u2 cos theta 2 because it's initially moving in this direction. Okay, so left hand side is negative. Similarly for y of particle 1 is going to be u1 sin theta 1, the initial vertical velocity, minus gt, acceleration is acting downward, and similarly for particle 2. Now if these particles, particle 1 and particle 2, are going to meet after some time in space, so what's going to happen? So suppose this particle is going to travel along this path, it's going to travel along this path, and it was destined to land here, and this particle had to travel something like this. Okay, so if there's a possibility for these guys to meet, they are going to meet here. Okay, and suppose it's given that these particles are going to meet, and then you have to calculate their respective parameters, and what time they are going to meet and what will be their velocities. So we can calculate it very easily. The only thing that you have to keep in mind is that when this particle 1 is going to meet to particle 2, their position vectors are going to be same. So suppose this particle is at here, this point is point P, so position vector for particle 1 is also P, position vector for particle 2 is also P. So the position vector, let's call it RP. So what I'm going to say, position vector of particle P1, or maybe let's just call it 1, position vector of 1 is going to be equal to position vector of 2, right? And this position vector is going to be consisted of two components. This is going to be r1x I plus r1y j, right? And similarly I can have the second particle. This is going to be r2x I plus r2y j. Now there's nothing new here, right? This r1x is basically the final position of particle 1, this x1 thing, and similarly r1y is nothing but this y1. R2x is this x2 and r2y is this y2. These are the final corresponding like x and y coordinates. Okay, so if they are going to meet, this x1 has to be equal to this x2 and this y1 has to be equal to this y2. So if you look at this equation, I'm going to equate this x1 to this x2 and this y1 value to y2. Now if I'm going to solve for the time, the equations are going to look like this x1, that was u1 cos theta 1 t, and this x2 was r minus u2 cos theta 2 t. Here you can see that here this is r minus u2 cos theta 2 t. So if if I'm going to solve for it, I'm basically going to get r is equal to u1 cos theta 1 plus u2 cos theta 2 into t, and this time can be written as r by u1 cos theta 1 plus u2 cos theta 2. Okay, similarly I'm going to equate for y1 is equal to y2, and if you see this equation, y1 is equal to y2, so the equating like these guys, this minus half gt square is going to be cancelled out from both sides, and again I'm going to like transfer this right hand side to the left, and this u1 sine theta 1 t to the right. So I'll just do it here only. So h1 plus u1 sine theta 1 t is going to be equal to h2 plus u2 sine theta 2 t, and this can be written as t is going to be h1 minus h2 divided by u2 sine theta 2 minus u1 sine theta 1. Okay, sorry, right, so this is sine theta 1. So now the only thing that you have to keep in mind that this time and this time is going to be equal, so I'm going to equate this like this r by this whole thing is going to be equal to this h1 minus h2 and divide by this whole thing, and that is the relationship between h1 h2 u1 u2 theta 1 theta 2 and the r if I have a genuine possibility of those guys to meet. If that is not satisfied, obviously they cannot meet. Okay, so from the previous calculations we had two times, one I got for the x1 and one I got for the like x, and one I got for the y. So if I'm going to equate those times, here is what I'm going to get. This is the equation that I got from like the x1 is equal to x2, and here is what I got from y1 is equal to y2. You can see it here. Okay, and so in typical scenarios, the kind of problems that you're going to see is like they are going to ask sometimes like what is horizontal distance, and everything else will be given, and or they might ask like what is the initial value of h1 or what is the initial value of h2 or maybe u1 u2. You get the point. Okay, so anything in this whole equation can be required, and the rest of the values will be given. Other typical problems are they are going to ask you the time at which they are going to meet. So for calculating time, you can use any of these two equations. So this is valid equation number 1, you can say, and this equation number 2. You can use any of these two equations and you'll be able to figure out your time. Okay, so here's a problem that I've taken for this 2D motion, and so this is 5 √2 meter per second, initial velocity 45, 30, 20, initial height is 20 meters. For this particle to it's 10 meter, and this r is unknown. Again, I've taken this point as origin, and right hand side is positive x and upward is positive j. The question is if 1 and 2 meet mid-air, calculate this r, calculate the time to meet, and see the angle between v1 and v2 when they meet. So v1 is velocity vector of particle 1, v2 is velocity vector of particle 2 when they meet. So calculating this a and b should be trivial, but this part c is a little bit tricky. Pause the video now if you want to take some time to figure it out. Okay, Okay, so R is basically this whole thing, and you can see from here I can just transfer this lower hand side term, like lower term, to the right, and I'll get the same equation that I've written over here, and just plug in the values of u1, u2, h1, h2, and you'll get the answer. So this is going to be u1 cos theta 1, u1 cos theta 1 is 5 plus u2 cos theta 2 is 10 root 3, and h1 minus h2 is going to be 10 divided by u2 sin theta 2 minus u1 sin theta 1. So u2 sin theta 2 is going to be 10, and minus u1 sin theta 1 is going to be 5. So this gives me, this is going to be 5, 5, this is 2, 2, so this is 10, 1 plus 2 root 3 meters. Okay, so this is the value of R. Okay, 10 plus 10 into 1 plus 2 root 3. Now how to calculate time? Time is nothing but this value of R divided by this u1 cos theta 1 plus u2 cos theta. You could also have used this equation h1 minus h2. So since we already have this R value and we know these guys, so I'm just going to use this. It's just a matter of choice. So the time is going to be 10, 1 plus 2 root 3, this is your R, and u1 cos theta 1 plus u2 cos theta 2, you just calculate this value here, that was 5 plus 10 root 3, 5 plus 10 root 3, so this is 5, this is 5 plus 10 root 3 plus 10 root 3. Okay, and this is going to give me 2 seconds. Okay, so R is equal to 10, 1 plus 2 root 3, and t is equal to 2 seconds. Now comes the interesting part. How do you calculate the angle between two vectors v1 and v2? So forget about v1 and v2. If you have any vector a, suppose a and b, and we want to find the angle between a and b, we have the dot product rule, right? So we have this a dot b is a mod b mod cos theta, right? So cos theta is going to be a dot b divided by a mod into b mod. Okay, so if I am able to figure out this a vector and the b vector, I'll get my cos theta, and from here the theta is going to be like cos inverse of a dot b divided by a mod into b mod. Okay, this should be easy. And so all I have to calculate this v1 vector and my v2 vector. Now if you have noticed, I have already given you the functional forms of v1 and v2. Okay, so let's see here. This is my v1 vector and this is my v2 vector. These are just the components. So this is the x component of particle 1 and y component of particle 1. Similarly, this is vx2 and vy2. So if I have to figure out the vector form here is nothing but u1 cos theta 1 I plus u1 sin theta 1 minus gt j. Similarly, I can figure out the v2. Okay, so let's see the values. So this v1 value is you're going to put the values for u1 cos theta 1, and this t is also known. So this is 5i plus this is going to be 5 minus 10 into 2j. So this is directly becomes is going to become 5i plus negative of minus 15j. Okay, and similarly we're going to calculate v2. You're going this is going to be the x component and this is going to be the y component. So this goes with I and this goes with j. So putting the values, you're going to get v2 is equal to minus 10 root 3 root 3 I minus 10 j. Okay, and again as I told you, you can figure out the angle that cos theta is going to be v1 dot v2. Cos theta is going to be v1 dot v2 divided by v1 mod into v2 mod. Okay, and like doing the maths bit, you're going to get 3 minus root 3 divided by 2 root 10. So this is your cos theta, and theta is nothing but cos inverse of this whole thing. And like if you're going to calculate this value, this comes out to be something around like 78 degree.